All right, we're going to go ahead and identify this as our function, and we want to find the derivative function using the first principles formula. So I'm just going to write the function down first. Now, back in our notes, we're going to be using this derivative function formula, which we call the first principles. So I'm just going to go ahead and write that down. Okay, we're ready to use our equation. So the first part is saying f of x plus h. So we're trying to evaluate the original function for x plus h. So wherever there's an x, we're going to put in x plus h. So I'm going to do that first. So I'll do that in purple. So you have your 1/2 x plus h all squared minus x plus h and then minus 2. So this is your original blue function, but you're replacing the x and the x with x plus h. Then the next part says subtract the function. So subtract the quadratic. And then it's all over h. Now for me not having to rewrite this entire problem again, I'm going to just cross out that x plus h all squared and write it as two binomials, because I have to FOIL those. And that's what we'll be doing next. So in the purple, we have to FOIL. So first, outside, inside, and last. And then we're going to distribute that negative x in front of the x plus h. So that's going to become a minus x and a minus h. And then we have a minus 2. In the green, in order for us to drop that bracket, we have to distribute a negative into all of those terms. So we're going to get a minus 1/2 x squared, a positive x, and a positive 2. All over h. These two middle terms are alike, so I'm just going to combine them into 2xh. Now we need to distribute this 1/2 into those three terms. So we get 1/2 x squared. 1/2 of 2xh is xh, and then 1/2 h squared. And then we have a minus x, a minus h, a minus 2. And then in the green, we still have that minus 1/2 x squared plus x plus 2 all over h. Now there's going to be some terms that are going to cancel out. I have a positive 1/2 x squared and a negative 1/2 x squared. They become 0. I have a negative x and a positive x. They become 0. There's a negative 2 and a positive 2. So what are we left with? We have xh plus 1/2 h squared minus h all over h. Now we're going to take out the GCF of the numerator, which is h. So we're left with x plus 1/2 h minus 1 over h. When we do that, we have a common factor of an h and an h. So those become 1. All right. Now we're ready to substitute 0 in for h. When you do that, this becomes 0. So your derivative function or your gradient function, f dash x, is x minus 1. In part B, they're asking us to find the gradient or the slope of the tangent line at point P. So here's point P on our graph. We're going to go down and identify that point on the x-axis as -2. So we're going to evaluate the derivative function for -2. So we're going to replace that x with -2, which is -3. So this is telling us that the slope of that tangent line is -3. So here's what that tangent line could look like. And it would have a slope of -3. The last part says the point at which the tangent has a gradient of 4. So we're saying that the gradient, the slope of the tangent line, is 4. So our derivative function is f dash x equals x minus 1. And what we're going to do is we're going to substitute I'm going to write this over here. The derivative function is going to equal 4. So we're going to substitute 4 in for f dash x, because that's the slope. And then we're going to solve it for x. So to solve this equation for x, we're going to just add 1 to both sides. So on our x-axis, if I increase this curve and I go over to 5, so here's 3, 4, it's not letting me, 4 and 5. It's not letting me write that, oh no. Anyways, we want to find out what is this point. So how you find the point is you're going to take the function f of x of 1/2 x squared minus x minus 2, and you're going to substitute 5 into that function. So when we're done, when we use our calculator, that's 11/2, or 5.5. So the ordered pair is 5, 5.5. So this would be the slope of the tangent line, and this would be the point that it would happen. So where is that on our graph? Somewhere up here, over 5, up 5.5, the slope of this tangent line would be 4.